Okay, so moving to the quadratic models. So quadratic model presents quantities that are not linear, okay? So that are non-linear, which do not have a constant rate of change. When we're talking about the table of value, which difference would be constant?
Second.
The second difference. How would the parabola look like? I already answered the question. How would the graph look like?
Parabola.
A parabola. So it's called a parabola. What degree would the equation have?
Second.
Second. And it's written in a form. Now there's multiple formats for it, but the one that we, the standard one is y equals ax squared plus bx plus c, where a cannot equal to 0, because the minute that a is equal to 0, then you lose the x squared term, and you're left with a linear function. Okay? All right, so in a table of value, if you have a table of value, you have to do your first difference. If your first difference is not constant, then you move to your second difference to prove if it's quadratic or not. So the question here, which models represent a quadratic relation? Okay, so in a table of value, you have to do, again, y2 minus y1. So you're gonna get minus 12. 202 minus 238 is minus 36. 142 minus 202 is negative 60. Right? As you can see, the first difference is not constant. Right?
Yes.
So I have to move to the second difference. So if I do negative 36 minus negative 12, that's going to be negative 24. And if I do negative 60 minus negative 36, that's going to be negative 24. Right? So that's an indication that since your second difference is constant, that means
It's quadratic.
it's quadratic. So second difference is constant. Therefore, it's quadratic. Okay? Same thing for the second. So you're going to subtract 48 minus 32, you're going to get 16. 72 minus 48, you're going to get 24. And then and then 108 minus 72, you're going to get 36. Okay? First difference is not constant, so we know it's not linear. So we have to test the second difference. So if I do the second difference, 24 minus 16, I get 8. And then 36 minus 24 is 12. So the second difference is not constant, right? So that means it's not quadratic. Are we okay with this?
Yeah.
All right. Now, moving to looking at graphs. Look at the both graphs and tell me which one's quadratic and why.
The first one.
First one's quadratic because
It's parabola.
it's a parabola shape. Second one is what?
Linear.
Okay. Graph of the parabola. So it's quadratic. Graph is a line. Therefore, it's not quadratic. How about the next? So these are equations. Looking at the equations, what can you tell me about the first one? Quadratic because it's a degree 2. Highest degree is 2, right? So it's quadratic. How about the second one?
Degree 1.
Degree 1. So
It's
it's not
linear.
quadratic. It's what is it?
Linear.
Easy?
Yep.
Good. Okay. So often when we are looking at real world situations, the formula that we have includes 3 variables. Okay? So for example, if you're looking at the volume of a cylinder, you have the volume, you have the radius, and you have the height. So you have 3 variables, and it's not good to solve with 3 variables. Okay? So we have 2 in this case that are dependent. So these 2, the radius and then the height, they are dependent on the volume. Sorry.
On
The volume is dependent on the
Okay.
radius and the height. Okay? So the volume is going to be on your y-axis. Radius and height cannot both be on the x-axis, right? So one of them can. So what happens in this situation, we're going to have to set one of them to be a constant. So we're going to say we're going to solve the volume if the height is blah, 10. Okay? For example, I'm just giving you examples here. So in the case when you have 3 variables, you're going to have to set one of them to be constant. Okay? So so which one is the dependent? So dependent is V,
Volume.
the volume. And it depends on
height, radius,
the radius
and height.
and height. So to determine the relation between the dependent variable and one of the independent, we have to set the other independent variable to some constant value. Rearrange the equation to solve for the dependent variable, which in this case we already know the dependent is volume, so you don't have to really solve anything. And then determine if the relation is linear, quadratic, or some other nonlinear functions. Okay? So basically the question is going to say set this to be a value. Set H to be whatever. Set R to be whatever. Okay? So we'll give you a value for these letters. Let's look at the example. So the formula D equals 1/2 AD squared. Give the distance traveled by a car as it accelerates from a stop position where D is the distance traveled in meters A is the acceleration in meter per second squared, and t is the time elapsed in seconds. Which one is your dependent variable?
D.
D. D is your dependent, and what are your independents?
A and T.
A and T. Okay? So investigate the relation between D and A if T is 2. So you see that they gave you a value for one of the independent, right? In this case, they set T equals to 2. So all what you have to do here, you're gonna have to say D equals to 1/2 A, and then replace T with a 2, right?
Yep.
And that would be D equals to 1/2 times 4 times A, which is 2A. Okay? Simplify it. Now, what can you tell me about this relation or this relation right here? Is it quadratic? Is it linear?
Linear.
Linear, degree 1, right?
Yep.
You see that the A have no degree on top of it, which is degree 1. Okay? So that's a linear relation. What's your slope?
It's 2.
Straight. What's your y-intercept?
It's 1.
Nope.
0.
0.
Okay.
Okay?
Yeah.
So it's 2A plus 0, right? Because
Yeah.
there's nothing here for D, right? So this is gonna be your y-intercept. Okay, good. Are you guys okay with this?
Yep.
Good. Now, the second part of the question, investigate the relationship between D and T, where A is 2 meters per second squared. So now we're replacing A with 2 meters per second squared. So to replace A with 2, 2 times 1/2 is 1. So D equals to 1T squared. I don't have to write that one. So messed up.
Quadratic.
Quadratic, degree 2, right? So see, in this case, it depends on which independent you set to be constant, right? If you set the A to be constant, then you're gonna end up with quadratic. If you set the T to be constant, you're gonna end up with linear. Okay? Are we okay with this?
Yeah.
Everyone? It's okay with that. Good. Now, you see how we used linear regression in the previous question when we were using Excel? Okay? We're gonna do the same thing, but we're gonna use sometimes regression. And we try the quadratic regression when we have a curve, best fit. Okay? When our data are a little bit curvy, and then we suspect that it might be quadratic. Okay? So we're gonna do the same thing. We're gonna go to Excel, and then we're gonna create a table of values, and then we're gonna do the regression. Okay? So a fountain of sparks from a Canadarm rocket follows an arc in the air. This table shows the height of the spark at various horizontal distance from the launching point. We're going to use a graphing technology to determine the equation of the parabola of best fit. It's telling us it's a parabola, so we know it's going to be quadratic. So I'm going to go to the Excel document. You can open a new sheet. If you guys see at the bottom, there's that plus next to sheet 1. So you can open a new sheet if you want. And then we're gonna enter the data. So and then in the same way, I have to highlight the numbers only. Go to insert, scatter, and pick the first. As you can see, this is a pretty good scale, right? I don't have to change my scale. My points are using the whole space. They're not only cluttered in one area. I see that this is kind of like going up, reaching a max, and then it looks like it's gonna come back down. It is coming back down. So I need to add axis. So make sure you press on the plus sign, axis title, make sure you include the label. So Y is the height. And then the unit, put it in bracket next to it. And then the axis title for the X is distance. Also include your unit in brackets. For the chart title, you can look at the question and then kind of get something. So so you can say height of a spark at various horizontal distance. Okay, I find a better one. All right. Are we okay up to this point?
Yeah.
Now what we're gonna do, we're gonna press again on one of the points, right click, add trend line. I want you guys to pay attention for a second, please. So when you're adding trend line, there's nothing that's called quadratic, right? But there's something called polynomial. When you say polynomial order 2, it's saying that it's quadratic. If you pick polynomial order 3, then it becomes cubic. Okay? So that's why we pick polynomial order 2. And then display equation on the chart and display the R squared on the chart. Are you guys okay with this? Now, a lot of times this could give you something that with an E letter, right? So you have to know what that is. Also, I want you to pay attention for a minute because that's going to be for tomorrow. So tomorrow you're going to be picking the first one, which is exponential. Okay, because tomorrow's lesson is about exponential. Can I have your attention, all of you? So you're going to pick exponential for tomorrow. Okay? Most likely the graph that the equation is going to be given to you, you're going to have an E. You see that E? Come on. I'm trying to make it bigger and I can't. Do you guys see that E?
Yeah.
I can make it bigger. Okay? So you can't use that E in your equation. You have to change it. So to change this, you're going to use your calculator. There is an E button on your calculator. You're going to have to press that. And and then you're gonna have to put the exponent. So e to the power of 0.0311. And that's gonna be your base. Okay? So your equation, instead of looking like this, did you all find the e?
Yeah.
E exponent.
Yeah. Second shift E.
Yeah?
It doesn't.
Shift. Yes. So e, and then you have to put it to the power of, oops, 0.0311. What do you get? 15.64? 50.64?
0.0311.
Yeah, what do
I
you
get
get?
1.0.
1.0.
Yeah, that makes more sense. Oh, you don't include that fully. Okay, so just do the e to the power. Okay, so when you enter the e to the power of 0.0311, you're gonna get what?
1.0.
Okay, so this is your initial.
Yeah.
Okay, remember with exponential, this is your initial. So your initial is gonna be 49.097, and then times 1 point, what did you say? 1.031.
Yeah.
Okay, and then to the power of x. Eyes on the board for a second, please. Okay, so whenever you do that exponential tomorrow, not today, today this is wrong, this is totally wrong, okay?
Yeah.
But for tomorrow, when you do the exponential, it's gonna give you most likely an equation that looks like this. Remember that the first number is your initial.
Yeah.
Remember the equation is a, b to the power of x,
Yeah.
where a is your initial, b is your base, okay? Your base is e to the power of 0.0311, but we can't leave it like this. So we have to change it to the actual base, which is in this case 1.0031,
Yeah.
and then to the power of x. Okay? So when you write the equation for me on the assignment, you have to write it like this. I will not accept it like that. Do you guys understand that? We're all good? Okay. So let's go back to this question and change it back to quadratic. So add trend line, polynomial, order 2, display equation, display r squared. You see that the r squared is 1, so that's the perfect r squared, okay? So that means it's a perfect fit. All right? And then do the same thing. So I have to, do you guys remember how to snip it? Okay, so snip it and add it to your Word document. I'm gonna use another snipping tool so I can add it to my slides. Okay, mine's a little bit different than yours. Because remember, I'm not using Word document. Okay, so this is my graph. And that's asking you to determine the maximum of the regression curve and what does it represent. So for this, can I have your attention? You can go back to your Excel sheet and then you are going to look at your graph and then you're gonna kind of locate where your maximum is. Where's your maximum? Where do you see the maximum is? What X value?
20.
At 20? I think it's
it's
somewhere right
20.
here.
Between them.
I think it's between 20 and 25, right? Somewhere right here. Right?
Yeah.
So what you can do, you can actually, if you want, you can just estimate what would it be. Okay? So at 23, it's about 119. Or what you can do is you can plug in 23 into X and find the answer. Okay? So since it's 23, what I can do is I can go to So I estimate that it's right here. Right? So what I can do is, I know it's about 23 right here, so I plug in 23 into the equation. And then find the answer. So the max is at 23 and about 110. Right? So remember, this is an estimate, this is not an accurate result, right? And this tells us that the maximum height the firework reach is at 110 meters. Okay, after at a horizontal distance